Hey guys, welcome to lesson 17.1, first lesson for second semester. This one's about identifying arithmetic sequences, and you're going to pick up with me on page 301. So remember, if this is the first mix you're doing with me, make sure that you aren't just watching and doing this passively. The idea is that you would be actively participating in the mix, so you'll pause it, try answering some things yourself, and then play it and see if you were having similar thoughts or if there's anything you need to add to your thinking. So do your best and let's get started. So this lesson is about identifying arithmetic sequences. So basically you probably just need to know what one is and then you'll be able to identify it. So first you got to know what a sequence is, and remember a sequence is just a list of numbers. And then we're going to identify sequences that are arithmetic sequences. So we're going to use the common difference to determine a specified term of an arithmetic sequence. So those are the two things we're going to do in this lesson. So they say use toothpicks to make the following models. We're going to use imaginary toothpicks. Unless you want to go get some toothpicks, then go ahead. And so here is stage 1 of the model, stage 2. So basically for each stage this corner inverts, flips up, so it becomes like this, and then you add 1, 2, 3, 4, 5, 6 more toothpicks. So on the third one then you invert these two corners so they flip up, and then you add 6 more toothpicks. So we're supposed to continue to stage 4 and 5. So here is my drawing for stage 4 and for stage 5. So each time I need to flip up the corners and then add 6 more toothpicks. So since we added 6 toothpicks each time, then when we fill in the table here for each stage, I would get 14, I'd get 20, 26, and 32. And we're supposed to use the following grid to make a graph of the data. So that's pretty straightforward. 1, 8, 2, 14, 4, 26, and 5, 32. Is our graph discrete or continuous? And it says explain. Now I'm going to say this over and over, but hopefully you'll just become second nature. You should try to answer these, pause the mix, answer them, and then listen, just to see if, of course it makes sense when I say it, but you want to make sure you're coming up with these things by yourself. So this one is discrete, and it says explain our answer. So the stages, each stage stage is a whole number, or stages are whole numbers. So you're not going to have stage 1.5. Each stage you're going to have a new image, and then the number of toothpicks. The toothpicks are whole objects also, and each time you do another stage, you're adding an entire set of toothpicks. So you could take it even farther than that. So, but mainly the deal is we're talking about whole toothpicks and whole stages. Is it a linear function? Yes. The points are on a line. How else could we tell? Think about that. Hopefully you would say that we could look at the table or the graph and say that it has a constant rate of change. That's what makes it linear. And remember, when you're looking at rate of change, you're always looking at change in y over change in x. Don't do it upside down. It's rise over run, not run over rise. So a little vocabulary here on this one. First of all, how to read it. This here is read as a sub n. It's a subscript, like y sub 2 minus y sub 1, and so on when you're finding slope. So this says an ordered list of numbers is called a sequence. That's the definition of a sequence. It's a list of numbers. The numbers in a sequence are called terms. To refer to the nth term in a sequence, you can use either function notation, f of n, or the indexed variable a sub n. So for example, if I wanted to find the 17th term in a sequence, I could say a sub 17. Or I could say f of 17 if I wanted to put it in a function. So the toothpick data form a sequence. The numbers of toothpicks at each stage are the terms of the sequence. So what are the first 4 terms of the toothpick sequence? Well, at the first stage there were 8, then there were 14, and the third term was, 20. I said third term and wrote a 3. The third term was 20, and the fourth term was 26. In a sequence, what is the distinction? Now here's where this is important, because when you try to use words to describe things, you've got to have that vocabulary under control. So the distinction between a term and a term number, well, a term is a number in a sequence. It's just one of the numbers. And the term number gives a term's, let's say, it tells us where it is. So maybe the term's position in a sequence. So it tells us where that term is. So for this sequence on number 7, 7, -5, -3, 1, and 1. What is the fourth term? That's what this says. A sub 4 would be the fourth term. So 1, 2, 3, 4, it would be 1. And what is the fifth term here? 1, 2, 3, 4, 5. A sub 5, or the fifth term, would be 17. So now we need to add a little bit more to our vocabulary. We know that a sequence is an ordered list of numbers. And a little bit of reading here. A common difference, we're going to get to that in a second. Common difference may also be called a constant difference. It means it's something that's always the same. So to differentiate an arithmetic sequence from any sequence, an arithmetic sequence is a sequence in which the difference between terms is constant. So between every term, it's the same amount. The difference between consecutive terms in an arithmetic sequence is called the common difference. So if there is a common difference between the terms, the difference is always the same. We have what's called an arithmetic sequence. It's spelled like arithmetic, but when it's used as an adjective for a sequence, it's called arithmetic. Explain why the toothpick sequence is an arithmetic sequence. Do you remember what it changed by for every stage? Think about that. What makes it arithmetic? There was a common difference or constant difference of what? Do you remember? Of 6 for each stage. I was going to end the sentence there, but well, we'll say that. What is the rate of change for the toothpick data? 6. We sort of just already answered that. It increases by 6 for each stage. So we should probably write that. Increases, because rate of change asks really for a little bit more information. Increases by 6 for each stage. Look back at the graph in item 4. So you'll have to look back at yours. I can see mine here on a book. So determine the slope between any 2 points on the graph. Now be careful with your scale. It might look like it's going up 1 over 1, but it's really going up 6 over 1. You could also use the table to see that. So it's changing. So the change in y over change in x from between any 2 points on that graph, it's going up 6 every time we're going over 1. So 6. Describe the connections between slope, the rate of change, and the common difference. They are all 6. So they're all the same. They are all equal. The common difference, the rate of change, and the slope are all the same thing in an arithmetic sequence. Hey, that wasn't too bad, right? All right, we'll see you in class, and we'll pick up on page 161.